Titration of sodium bicarbonate with hydrochloric acid. We begin this experiment by making a solution of sodium bicarbonate, and in order to make this solution we will need a volumetric flask in which we are going to place a known mass of sodium bicarbonate, which will be determined by measurement on a scale. And we are going to add small increments of water to this until all the sodium bicarbonate is dissolved. So you add a little bit of water, swirl it vigorously, and after no more sodium bicarbonate dissolves, you add a little bit more, swirl it vigorously, and keep adding until all the sodium bicarbonate is fully dissolved. Once it is fully dissolved, you start adding more bravely increments of water until the water level is up to the mark on the volumetric flask. At that point, you stop. You add the cap of the volumetric flask and you gently tilt it side to side a couple times until the solution becomes homogeneous. If you follow this process, you will have a homogeneous solution with all the sodium bicarbonate fully dissolved. Now, in order to determine the concentration of the thus prepared sodium bicarbonate solution, all you need to know is the mass of the sodium bicarbonate, which in step 1 gets converted to moles. We take the 1.06 grams of sodium bicarbonate, and we're going to say that 1 mole of sodium bicarbonate weighs 84 grams of sodium bicarbonate. The grams of sodium bicarbonate cancel, and we're going to have moles of sodium bicarbonate. Our calculation shows 0.0126 moles of sodium bicarbonate. Once you know the number of moles, you will have the volume from the volume of the volumetric flask, and you can simply take your moles divided by your volume, convert it to liters, and get the concentration. So the concentration of sodium bicarbonate, you can write it this way, or you can just say molarity of sodium bicarbonate is, you have the moles on top, 0.0126 moles of sodium bicarbonate, divided by 100 milliliters, converted to liters, is 0.1 liter. The result of this calculation is 0.126 molar. Otherwise, we can write it as 0.126 moles of sodium bicarbonate per liters of solution. We made a solution. Titration is a quantitative analytical technique in which we have a standard acid that is in the burette up here. In our case, that is hydrochloric acid, and we're going to slowly add this into an Erlenmeyer flask that contains our base. In our case, the sodium bicarbonate is our base, and our indicator is methyl red. Methyl red is yellow when it is in a basic solution, and as more and more acid is added, it will slowly turn to orange and then red when it becomes acidic. As the titration progresses, we're looking at a transition from yellow to an orange or golden orange color. To perform the titration, we're going to place our sodium bicarbonate solution and a few drops of methyl red indicator into the Erlenmeyer flask on the bottom, and we're going to charge our burette with hydrochloric acid. Before we do anything, we will record the volume of the sodium bicarbonate solution that we placed inside the Erlenmeyer, and we're going to have the initial volume reading on the burette for the hydrochloric acid. Then we titrate our sodium bicarbonate solution with hydrochloric acid by adding the acid in small increments until the color goes from yellow to orange. At that point, we're going to record the final volume of the hydrochloric acid in the burette. With all these measurements in place, we're ready to do some calculations. And step 1 is always going to be the same determine the volume of hydrochloric acid consumed. To do that, we're going to take the final volume, which is 28.38 milliliters, and we're going to subtract the 0.21 milliliters from it. The difference between these two is 28.17 milliliters. With the volume of the hydrochloric acid solution obtained, we're ready for step 2, where we can calculate the moles of the hydrochloric acid that was consumed in the course of the titration. So we start with the volume of the hydrochloric acid consumed, 28.17 milliliters. In step 1, we're going to convert the milliliters to liters. And in step 2, we're going to say that in every 1 liter of the hydrochloric acid solution, we have 0.1 moles of hydrochloric acid. And that's where we stop. The milliliters and the liters will cancel, and we're going to have 0.002817 moles of hydrochloric acid. In step 3, we're going to consider the mole ratio in the chemical equation that describes the reaction between hydrochloric acid and sodium bicarbonate. We start with the moles of hydrochloric acid, 0.002817 moles of hydrochloric acid. We're going to use the mole ratio. Every time we react 1 mole of hydrochloric acid, it will consume 1 mole of sodium bicarbonate. The moles of hydrochloric acid cancel, and we are left with 0.002817 moles of sodium bicarbonate. Once we have the moles of sodium bicarbonate, we can determine both the concentration of the sodium bicarbonate solution and the mass of the sodium carbonate that was inside. So let's start with determining the mass. We had 0.002817 moles of sodium bicarbonate, and we know that every 1 mole of sodium bicarbonate weighs 84 grams of sodium bicarbonate. The result is 0.24 grams of sodium bicarbonate. Next, let's calculate the concentration of the sodium bicarbonate solution that we prepared. We have the moles of the sodium bicarbonate, 0.002817 moles of sodium bicarbonate. And we divide this by the volume of the sodium bicarbonate solution that we titrated, which is 22.48 milliliters, except in order to calculate molarity, we have to take these milliliters and convert them to liters. We can do this relatively easily. It's 0.02248 liters. This ratio gives us 0.125 moles per liter for the sodium bicarbonate solution. If you remember our earlier preparation of this solution, we estimated that it would be 0.126 moles per liter. We find in the titration that it's 0.125 moles per liter, which means we did a pretty good job both with the preparation of the solution as well as the titration of that solution with the hydrochloric acid solution in the presence of the methyl red indicator.